Hi, welcome to my YouTube channel. My name is Jane. I would like to take you through a 3x3 matrix. We have an example here. Given a matrix A is equals to 1 0 4 0 2 0 3 1 minus 3. Determine the eigenvalues and the eigenvectors. So we are going to determine the eigenvalues, and we know that we use the formula A minus alpha, we multiply by the identity matrix is equals to 0. So our original matrix A is 1 0 4 0 2 0 3 1 negative 3. That is our original matrix A minus alpha. We multiply by the identity matrix, which is 1 0 0 0 1 0 0 0 1 is equals to 0. So we are going to have 1 0 4 0 2 0 3 1 negative 3. We minus the product of our eigenvalue with the matrix, that is alpha 0 0 0 alpha 0 0 0 alpha is equals to 0. So 1 minus alpha, we are going to have 1 minus alpha. 0 minus 0 is 0. 4 minus 0 is 4. 0 minus 0 is 0. 2 minus alpha. 0 minus 0 is 0. 3 minus 0 is 3. 1 minus 0 is 1, and minus 3 minus alpha is equals to 0. So this is the resulting matrix from subtracting this matrix from our original matrix. From here we are going to find the determinant. So for finding the determinant, we have the sign position of the columns. So we have positive, negative, and positive. So we are going to take the first element, we cross the column with the row. So we are going to remain with these 4 elements, that is 2 minus alpha, 0, 1 minus 3 minus alpha. So 1 minus alpha, we are going to remain with, after crossing this column with this row, this 2 minus alpha, then we multiply, that is, and 0, then 1 minus 3 minus alpha, then we go to the next element, which is 0, negative, so it is minus 0. So we are going to cross this row with this column, so we are going to remain with the 0 0 3 minus 3 minus alpha. So it is 0 0 3 minus 3 minus alpha. Then the other one is a positive 4, and the value of 4 is positive, so it is plus 4. After crossing the column and there's a row, we are going to remain with the 0 2 minus alpha 3 and 1, then it's equals to 0. Then after that, to determine the determinant of a 2 by 2 matrix, we multiply the diagonal, we minus this diagonal. So you are going to have 1 minus alpha, 2 minus alpha, we multiply by negative 3 minus alpha minus 1 times 0. Then the multiplication of all these matrix will be equals to 0. So minus 0 plus 4. So 0 times 1 minus 3, 2 minus 1 alpha is equals to 0. So we are going to remain with 1 minus alpha, 2 minus alpha, we multiply by negative 3 minus alpha, then plus 4, we're going to remain with negative 3, 2 minus alpha is equals to 0. Then if we look at this expression, 2 minus alpha is common with this one, so we are going to remove it on our out of the bracket. So we have 2 minus alpha, then we have 1 minus alpha minus 3 minus alpha, then plus 4, 3 minus 3 is equals to 0, because now this is common. So you are going to have 2 minus alpha minus 1, that is 1 minus alpha minus 3 minus alpha minus 12 is equals to 0. So 2 minus alpha is equals to 0. Therefore, alpha 1 will be equals to, that is our first eigenvalue, will be equals to 2. Then we are going to remain with 1 minus alpha minus 3 minus alpha minus 12 is equals to 0. So we are going to find the product of these two expressions. So 1 into bracket minus 3 minus alpha minus alpha minus 3 minus alpha minus 12 is equals to 0. So you have minus 3 minus alpha plus 3 alpha plus alpha squared minus 12 is equals to 0. So we have a quadratic formula, which is alpha squared plus 2 alpha minus 15 is equals to 0. So you are going to find the factors of this quadratic formula, where we have alpha squared plus 5 alpha minus 3 alpha plus 15 is equals to 0. So we get the factors alpha plus 5 minus 3 into bracket alpha plus 5 is equals to 0. So we have alpha minus 3 is equals to 0, and we also have alpha plus 5 is equals to 0. This one giving us alpha 2 is equals to 3, and this giving us alpha 3 is equals to negative 5. So our eigenvalues are eigenvalue 1 is 2, eigenvalue 2 is 3, and our eigenvalue 3 is equals to negative 5. The next video will be determining the eigenvectors of a 3 by 3 matrix. Thank you for watching my video. For more videos, open my YouTube channel. Don't forget to share, like, and subscribe. Thank you.